Okay, this is SP Gubbi online classes for Ncert and 10th standard Cbse for mathematics and science classes, right? So in the last session of physics, we had learnt refractive index, absolute refractive index, and numericals on it. You have written a test on it, so it was a good performance. So regarding the test, we also had a orientation program which was very successful. I hope you have scored good marks in that. So in today's topic, we will be going with the most important part of the chapter, that is heart of the chapter, that is lenses, which is also very easy. So this class will be the fundamentals of lenses, which is very important. You have to learn it, you have to understand the concept here, because after this we are going with sign conventions, we are going with magnifications, we are going with that is power of a lens, then we will be going again with numericals. So this class plays a very important role for the next coming classes to understand well, to do well in that, right? This class plays a very important role. Watch the video again and again so that you can understand the fundamentals, the basics to get a good grip on the topic, right? So in today's topic we will be going with lenses, right? So imagine two transparent refracting surfaces, right? Spherical surfaces. For example, let us go with this. So this is a transparent spherical surface. Let us take another transparent spherical surface. So refraction, we know what is refraction here. We are well aware of it. So these are the two refracting surfaces, right? Okay. So here, when we take this part of the two refracting surfaces, that is this part, that is from A to B, and if we take it out and see that, it looks like this. Approximately it looks like this. So this is a part, this is a refracting, that is a transparent medium. So basically it's a transparent medium which is taken out of these two refracting surfaces. So it's a transparent medium having two refracting surfaces, one at both the ends, that is one refracting surface, another refracting surface. In the sense, whenever light is made to pass through this material, the light is going to undergo refraction. So therefore, so it is one of the refracting surface, this is another refracting surface. So here, so in these two refracting surfaces, either one should be spherical in nature. It should be at least one should be spherical in nature. If both are spherical, it's well and good. At least one refracting surface should be spherical in nature. Then that transparent material having that refracting surface, having one or both spherical surfaces can be called as lenses. So what is a lens? What are lenses? So lenses are the transparent materials having refracting surfaces where at least one of its refracting surface is spherical. So this is called a lens. So I will repeat the definition. This is very important. You have to understand the definition here. You should feel the definition. So here, if a lens is a transparent material, which means it allows light to pass through it. So it is having two refracting surfaces. In the sense, whenever light enters into this transparent medium, the light is going to undergo refraction. So those refracting surfaces, by nature, they should be spherical. At least one surface should be spherical. So if this is the thing happening in a material, then that material can be called as a lens. So a lens is a transparent material made up of refracting surfaces where at least one refracting surface is spherical. So this is a lens. So lenses are said to be of two types. We will go with the first convex lens. So one is the convex lens, or it is called as converging lens. In other words, it is called as a converging lens. So what is the other name for convex lens? It is a converging lens. Why it is called a converging lens, we will discuss in the next coming minutes. Okay. So here a convex lens may be like this. So this is called double convex lens. This is called double convex lens. So why it is called double convex lens? Because one of the surface is spherical, the other surface is also spherical. Therefore, it is called a double convex lens or just convex lens. Right. So, other type of convex lens can be like this. So, where one of the surface may be spherical, and the other surface can be a plane one. So, therefore, this is called a convexo, or we can call it like this, plano-convex lens. This is also called as plano-convex lens. So, this is the material inside, that is the glass or whatever the material we have taken, that is inside this. So, this is double convex lens because both the surfaces are spherical. So, this is called plano-convex lens because it is one surface is spherical and the other surface is a plane. So, other type of convex lens also exist, that is it has one spherical surface and another surface is concave. So, this is also a type of lens. So, this is called as concavo convex lens. This is called concavo convex lens. So, this is one type of lens. This is the lens. Okay. So, these are the different types of, there is one type of lens. So, let us go with the second type of lens, that is concave lens. Concave lens, or in other words, the diverging lens. Diverging lens, concave lens or diverging lens. So, how it is? So, just imagine two spherical surfaces. This is one of the spherical surface. This is another spherical surface. So, in between these two spaces, what we get a material here. So, this is called as a concave lens. This is how a concave lens is made. Right. So, this is a concave lens. Right. So, if you take out this concave lens from here, it looks like this. So, this is a concave lens. Right. So, here we can see that it's a transparent material. It is usually a lens will also always be a transparent material. So, in this transparent material, it has two refracting surfaces, that is both are spherical, two refracting surfaces. So, this is the spherical part, so this is the another spherical part. So, these concave lens has two refracting surfaces where both are spherical in nature. So, it is a double concave lens or just it is a concave lens. So, you can call it as a concave lens. Okay, so this is one of the things. So, second one is another type of concave lens. So, one surface will be spherical, but the other surface will be a plane. So, this will be called as a plano-concave lens. It's called a plano-concave lens. So, this is another type of lens you can see here. So, one surface is spherical, but another surface is a plane. So, then we can go with another type of lens, that is concave lens. One side is spherical and another side is having a convex nature. So, convex nature in the sense it comes like this. So, here it is convexo concave lens. This is called as convexo concave lens. This is called convexo concave lens. So, these are the different types of lenses. One is convex lens, another is concave lens. Okay. So, in convex lens we have three types: double convex lens, plano convex lens, and concavo convex lens. In the other type of lenses we have concave lens. So, concave lens is in other words also called as double concave lens. So, it is plano concave lens because one side is a plane. So, this is convexo concave lens because one side is concave, another side is convex. So, therefore, it is called as convexo concave lens. So, these are the two different types of lenses we have come across. Right. So, now regarding this convex lens, we will go in detail. Right. So, let us see what is a concave lens, convex lens in detail. So, here this is a convex lens. So it has two refracting surfaces where both are spherical in nature. So this is a convex lens. Now, so a convex lens is a type of lens having two spherical surfaces, where it is thick at the middle, it is thick at the center, and it tapers towards the edges. You can see the tapering because it is thick at the edge, and the size of the lens goes on decreasing or tapering and ends that becomes very thin at the edges. So this can be called as a convex lens. A convex lens is a transparent material having two refractive surfaces which are both spherical in nature, where it is thick at the center and thin at the edges. See, these are the two edges. So it goes on towards the edge, it is going to become thin, and towards the edge it is going to become thin. So it is thick at the edges and thin at the, thick at the middle and thin at the edges. Okay, so this is a convex lens. Right, so this becomes a convex lens, right. So we'll go with the concave lens. Concave lens. So concave lens is also a type of lens in which it has two refracting surfaces where both are spherical in nature. And here, when you see a concave lens, it is thin at the center. You can see that it is thin at the center and it is thick at the edges. At the edges it is going to become thin, and at the center it is thin. So these are the two differences, main differences between a concave lens and a convex lens. So this is a concave lens. So you can see here it is thin at the center, and thick at the edges. So this is a convex lens and that is a concave lens. Now we will go with certain terminologies, terms which are connected with the lenses. Very important, these terminologies. With the definition you have to remember this, right. So first one we will go with the principal axis. Now here you can imagine this is the spherical part. So this is the spherical part, this is the sphere, this is the sphere somewhere here. You can get the sphere here. So for this I can get a sphere here. So this is the sphere. For this sphere, this is the center. Let us call it as C1. For this for this circle, that is circular shape, this becomes the center. That is, we will call it as C2. Right. So here the line joining the centers of the two spherical surfaces. The line joining the centers of two spherical surfaces is the line joining the centers of two spherical surfaces where lens is a part of it. Where lens is a part of it is called as the principal axis. So the principal axis of a lens. So what is principal axis of a lens? So very simple. Principal axis is a line joining the centers of two spherical surfaces where lens is a part of it. That's called the principal axis. Here also same thing happens. So here we can take this as a spherical sphere. So this is spherical in nature. For example, I am taking this. So this is spherical in nature. This is spherical. Okay. So this is the center of the first spherical sphere, that is C1. So this is the center of the second spherical sphere, that is C2. If I join these two center of curvatures, right, then this line is called the principal axis of a concave lens, right. So what is principal axis? Principal axis of a concave lens means principal axis, the line joining the centers of the two circular surfaces where the lens is a part of it. That's called a principal axis. Very, very important terminology. Principal axis. What is principal axis? Principal axis is a line joining the centers of the two spherical spheres. Two spherical spheres where the lens is the part of it. That's called a principal axis. So it's nothing but a line passing through the lens joining the centers of the two spherical spheres. So that is called as principal axis. So in mirrors also you came across the principal axis. So that was a different definition. Here it's a different definition. Okay. So I hope you understood this principal axis. Once again I will repeat this. The line joining the centers of the two spherical spheres where a lens is, a part of it is called as the principal axis. So here center of curvature is represented one by C1, another by C2. In the same case, this is C1 and this is C2 in case of concave lenses. So this is the principal axis. Right. Now we will go with the next terminology connected to the lenses, that is the optic center. Now we will go with the second one, optic center. Right. So now imagine a lens which is a convex lens, right? So this is the principal axis passing through the lens. So now a light ray, from nowhere, a light ray passes through the lens, but it goes out of the lens undeviated. If a light ray passing through the lens goes out of the lens without getting refracted, that means without getting refracted, if the light ray is going to pass through the lens and go away, then it is called that point on the lens. This point is called as the principal, that is optic center, which is represented by the letter O. So the same thing happens in case of a concave mirror also. So this is a concave mirror. So this is the principal axis here. You can take it. So another light ray passing towards, that is moving towards the lens, passes through the lens undeviated. So the light ray is not going to get deviated, because according to the rules, this is the rarer medium, the lens is a denser medium. So therefore the light ray has to pass from the rarer medium into the denser medium. It has to undergo refraction. It has to change its direction of path. That is, its speed should vary. You know what is refraction. But when this light ray passes through the center of this point, through a point of the lens which is undeviated, the light ray goes away through the lens undeviated. So that point on the lens is called as the optic center. This is optic center. It is represented by the letter O. Right. So what is optic center of a lens? Optics, when a light ray passing through the lens goes through the lens undeviated, then that point on the lens is called as the optic center of the lens. So here optic center is represented by the letter O. So in the case of convex lens, this the thing happens, and in case of concave lens, this the thing happens. Right. So we are with the two terminologies connected to the lenses. One is the principal axis, another one is the optic center. So both definitions, with good understanding, you should get it. Right. So we'll go with the next topic. Okay, we'll go with the next topic, that is principal focus. So until now we have learned regarding two topics. One is the principal axis, another is optic center. So we'll go with the next one, that is principal focus. So this is represented by the letter F. Right. So now let us take a convex lens. So this is a convex lens. This is the optic center, which is represented by O. This is the principal axis. Right. So this is the optic center. Now imagine light rays traveling parallel to the principal axis or incident on the convex lens. Okay. These are the incident light rays. Let us take this as the incident light rays traveling parallel to the principal axis. Okay. Now, so these light rays, now they are in the rarer medium, and the lens is the denser medium, and again it is the rarer medium. So as the light rays enter into the lens, they undergo refraction, because the light ray is changing, that is traveling from one medium to another medium of different refractive index. Therefore, they get refracted, and at this point they start traveling in this direction. That is, the refracted light rays, right, they travel in this direction. After refraction, they travel. So here, all these refracted light rays are going to meet at a point on the principal axis. That is, the refracted light rays, not reflected light rays. Reflection happens in mirrors. So this is refracted light rays. These refracted light rays are going to meet at a point on the principal axis, and this is called as the principal focus. Right. Next, let us see what happens with in case of a concave lens. So this is a concave lens. Okay. This is the principal axis. So let us imagine the light rays are traveling parallel to the principal axis. They are traveling parallel to the principal axis. Right. So these light rays after refraction, they are going to travel in this direction, because the lens what we are using here is a diverging lens. That is, the light rays are going to travel in this direction. But these light rays, they are traveling diverging. That is, the diverged light rays, they appear as though they are starting from a point from here. They appear as though they are starting from a point on the principal axis. So this point on the principal axis here is called the principal focus. So this is the principal focus in case of convex lens, and the principal focus in case of a concave lens. So this is the principal focus. So principal focus is represented by the letter F. It's the optic center. Okay. So here, next topic is the focal length. Let us define the principal focus, right? So principal focus is a point on the principal axis. It's a point on the principal axis where the light rays after refraction, they are going to meet at the point, or the light rays after refraction, they appear to meet at that point. So that's called the principal focus, right? Once again, what is principal focus? Principal focus is a point on the principal axis where the light rays traveling parallel to the principal axis meet at that point, or appear to meet at a point. So that point is called as the principal principal focus. So here the light rays actually meet at this point after refraction. Here the light rays appear to meet at a point on the principal axis. So appear to meet on the principal axis happens in concave lens, and the actual light rays are going to meet at a point on the principal axis, and that happens in a convex lens. So let us go with the next point, that is focal length. So here you can see this is the optic center and this is the principal focus. The distance between the optic center and the principal focus, this distance what we call here, this is called as the focal length, represented by small letter f. So here also the distance between the principal focus and the optic center, right, is called the principal, that is focal length. So this length is called as focal length, so represented by f, which is very, very important. So this is the principal focus and that is focal length. So principal focus is represented by big letter f, whereas the focal length is represented by small letter f. Okay. So we'll go with the next concept, that is principal foci. Principal foci. Okay. So here principal foci, F-O-C-I, foci. So here foci is the plural word, so plural word for focus. Focus is singular, foci is plural form. So principal foci, right. So here, take a convex lens. This is a convex lens. So light rays are passing through the lens in this direction. The same thing can also happen in this direction also. In the sense, the light rays can travel in the opposite direction also. In this direction also, the light rays can enter into the lens. For example, right. So in this direction also, the light rays may enter into the lens. As like in this direction also, the light rays can enter. So after refraction, the light rays are going to meet at a point on the principal axis like this. So here, as the light rays can enter in both the directions in a lens. Therefore, a lens has two focus. Two focus in the sense it has two foci, because the plural form of focus is foci. So this is also the principal focus. So if you call it as f1 and you can call it as f2. So therefore, a lens has two principal foci, right? Why? Because the light rays can enter in both the directions. So let us to identify better, let us take it as f1 and let us take this as f2. So here for focal length can also be taken as from f1 to O, that is from the first focus, from the first principal focus to the optic center, the focal length is taken as f1, and from the optic center to the second focus we can take it as, that is f2, that is focal length f2. So this can be taken. So in the coming problems are numericals, we are going to solve more problems on this, right? So once again, what is the principal foci? So as the light rays can fall on the lens from both the directions, therefore if the light rays are coming in this direction, in case of a convex lens, the image, that is the light rays are going to meet at this point. The light rays are coming in this direction, the light rays are going to meet at this point, and this is the focus. So therefore, for a lens, it has two foci. So it is f1 and this is f2, first principal focus and second principal focus. Now, the distance between the optic center and the first principal focus is called first focal length, and the distance between the optic center and the second principal focus is called as second focal length. Same thing happens in case of a concave lens also. Right, we'll go with the next topic. First principal focus, that is represented by f1. First principal focus represented by f1, right? Now, consider a convex lens. Consider a convex lens here. So it is a convex lens. This is the optic center. This is the principal axis, right? So this is a convex lens. Now, how to identify the first principal focus? That's very important. How to identify f1 or first principal focus? Very simple. The light ray starting from a point on the principal axis, try to follow this. The light rays starting from a point on the principal axis, after refraction from the lenses, if they travel parallel to the principal axis, then that point on the principal axis is called as the first principal focus. Very simple. So here is a point, that is f1. From this point, the light rays start traveling. Right. After refraction, the light rays are going to travel parallel to the principal axis. That is, they travel parallel to the principal axis. So if this is happening inside a lens, so this is the optic center. From a point on the principal axis, if the light rays start from that point, and after refraction, if they travel parallel to each other, that is parallel to each other and also parallel to the principal axis, then that is called as the first principal focus. So let's see what happens in a concave lens. So in case of a concave lens, right, so this is the principal axis, this is the optic center. Now, let the light rays fall on this mirror from some point, right? From a particular point, the light rays are falling on the, that is, lens. So after refraction, the light rays are traveling parallel to the principal axis. So this is what's happening here. They are traveling parallel to the principal axis. So here, these light rays, as they are coming towards the lens, they appear as though they are starting from this point. So this point is called as f1 in case of a concave lens. So this is a convex lens. What happens with a convex lens, and this is what happens with a concave lens. So this is the thing, right? So what is first principal focus? First principal focus is a point on the principal axis where the light rays are going to start at this point, and after traveling through the lens, that is after getting refracted from the lens, they travel parallel to the principal axis. If this happens in a lens, then that point on the principal axis is called as the first principal focus, right? We'll go with the second principal focus. Second principal focus, that is F2, right? So this is also very important. Second principal focus. Now, take a convex lens. Let us take a convex lens. So this is a convex lens, right? So this is the principal axis. This is the optic center, right? Now, so we have to concentrate on a point on the principal axis where the light rays traveling parallel to the principal axis fall on the lens and meet at this point. The light rays traveling parallel to the principal axis after refraction meet at this point. So that point we have identified. So here we can take we have taken the convex lens. So let us see in case of convex lens how to locate the second principal focus. So let us imagine these are the light rays traveling parallel to the principal axis, right? It's traveling parallel to the principal axis. After refraction at these points, the light rays are going to meet at a point on the principal axis. They are going to, after refraction, they meet at a point on the principal axis. So therefore, it is taken as F2. That is the second principal focus. So this is the thing what happens, right? So in case of a convex lens, the light ray should be already traveling parallel to the principal axis, and after refraction, the point at which they meet on the principal axis, that point is called as F2, and that is second principal focus. Okay. Let us see what happens in case of a concave lens. Okay, this is a concave lens. So this is the principal axis, this is the optic center. Okay, now the light rays, they are already, that means after traveling, that is after okay, let us take this point as F2. So what happens here is the light rays are already traveling parallel to each other. They are already traveling parallel to each other. In the sense, we have to write the light rays already traveling parallel to each other here. Okay, let us take these light rays, 2 are enough. Okay, so after reflection, they are going to get diverged. At this point, the light rays are going to get diverged. But these diverging light rays, they appear to meet at this point when they are drawn backwards. That is, they appear to meet that is they appear to start from this point from here. So therefore, this point is called as the second principal focus, represented by F2. So convex lens has F1 here and F2 here. Concave lens has F1 here and F2 here. So this is the main difference between the first principal focus and second principal focus. Alright. So now the distance between the optic center and the second principal focus is called second focal length, and the distance between the optic center and the second principal focus here is also called as the second focal length. Okay. So now we go with a very simple concept again, that is focal plane. The plane which is passing through the second principal focus is called as second focal plane. So the plane which is passing through the second principal focus is called second focal plane. So here also it is the plane which is passing through vertically through the second principal focus is called as second focal plane. So if it is passing through the first principal focus, then it is called first focal plane. That's all. So next we come for the aperture of a lens. Aperture of a lens means the surface of the lens which is exposed to the incident light rays is called as the aperture of the lens. What we had learned, the same thing in case of mirrors, right? The part of the surface of the lens where the incident light can fall on it, that's called as the aperture of the lens. So these are the very important things what we have discussed today. So all the things are very important here. All the terminologies are very important. So one among them is principal axis. Principal axis. So the line which joins the center of curvatures of two refracting surfaces where a lens is a part of it is called as the principal axis. Next we go with the optic center. Optic center, right? The light which passes through the lens, if the light ray passes through the lens at a point through the lens at that, then undeviated, then that point on the lens is called as the optic center, represented by the letter O. Okay. So next we will go with the principal focus. Principal focus, we have seen this. So principal focus. So whenever light rays travel parallel to the principal axis after refraction, if they meet at a point on the principal axis, then that point is called as the principal focus. So they meet at a point on the principal axis, or they appear to meet at a point on the principal axis. So if they actually meet at a point on the principal axis, then it is a convex lens. If they appear to meet at a point on the principal axis, then it is certainly a concave lens. So principal focus is represented by the big letter F, right? Now the distance between the optic center and the principal focus is called as the focal length. So if it is in between O and F1, it is called first focal length. If it is in between O and F2, then it is called second focal length. So focal length is represented by the small letter F. So F1 and F2 it differs. Next is principal foci. So as the light rays can fall on the lens in both the directions, so therefore a lens has two focus. Two is plural form, that is plural form of focus is foci. So one is taken as F1, another is taken as F2. So first principal focus. Okay, so this is over. Principal foci. Right. Next one is first principal focus. First principal focus represented by F1. So it's a point on the principal axis where the light rays start from the point on the principal axis, get refracted by the lens, and if they travel parallel to the principal axis after refraction, then it is called as the first principal focus. So next, second one is second principal focus. Second principal focus, that is F2. So it's a point. It's a point on the principal axis where the light rays travel parallel to each other, parallel to the principal axis. After refraction, they meet at a point on the principal axis. That is called the second principal focus. So next is the last one, aperture of lens. Aperture of lens. So aperture is the surface of the lens where the incident light can fall on the lens is called as the aperture of the lens. So these are all the terminologies connected to lenses. Very important things I have discussed. So all these things are very important. Please understand it to the basic level by heart, or try to recapitulate the definitions of each and everything. So know how it comes, how it is done, how it comes. So then only you will be good at solving numericals on lenses, right? So in the next class we will be going with the ray diagrams on lenses, which is again a very important class, right? So until now I hope you have enjoyed this session. So stay home, stay safe, and keep learning.